Hello, I'm Eddie. I would like to discuss how to use the Azure Machine Learning pipelines to automate the generation of the responsible AI dashboard. Um, this today I'll focus only on the let's get it working bit, and in following um, videos I'll talk about how do I interpret each one of those elements. So this is where I'm going to get to towards the end. So you've got one set of uh, training and test data sets, and, and I will apply to it three different models, and each model I will put for a process of generating a responsible AI, RAI dashboard for it. That's why we would like to automate it rather than doing it manually. Some of the features here are still in preview at the time of creating this video. I have spent more time than I care to tell you on trying to get things going. I think I've got most of the stuff that I wanted to go working correctly. There's one thing I'll show you where I'm still stuck, hoping that it will be resolved when it goes into general availability. As usual, it is complicated only as long as nobody has shown you how to do it yourself. One approach that Microsoft have taken to responsible AI dashboard is just applying good statistical practice and good statistical thinking. And some of the capabilities that are available there make sense. When you build a statistical predictive model or a classification model, or you do a computer vision model, there's a few things you would like to check and validate just to see that your model is good, using the lens and paradigms of responsible AI just makes the model even better. So usually when you do modeling, statistical modeling, you go through this process, you get the data, you smell it and taste it, you prepare some models, you check how good they are, and then you put them into production and monitor how well it is in MLOps. Microsoft have added another step, another component that sits after they evaluate. So after you've looked at, let's say, the correlations and precision and so forth, and can we look at the same things, but from the eyes of a particular subset of the population of the data, and see if the accuracies, the errors still hold for cohorts within the data itself. And this is the last slide I want to show about just high level, because I really want to dive into the how do I do this. There's a few ways of defining what is responsible AI, and there's loads of papers that high up there saying, oh, you need to be fair and you need to be accurate and private and accountable and explainable and so forth. Let's try and figure out how we do these things in the daily life of Azure Machine Learning practitioner, a statistician, a machine learning developer, and so forth. And one of the easiest things to talk about is fairness. So my next video will be focusing on fairness. It's a very important question, and there's a few tools to look into. So when you go into the demo that Microsoft provides, it's a very simple demo. You just, and I'll show you where to find it in a second. One of the things that comes out immediately is that choosing the right version is really, really important. And interestingly, when you create manually the dashboard through the user interface, for instance, for the AutoML blade, you'll get version 0.10, but the latest version is 0.14, and I'll show you in a second how to get to more. So let's start with a simple flow like this. So you've got two data sources. One of them is the trained and is the test. You apply some model to it. You create the dashboard. You do one of the analysis. You've got different choices. You can put here quite a few. and then you collect them into a report, and you can actually put them into a PDF at the end. So first is, where do I find the Microsoft example? So if you go to Azure Machine Learning and you go to the samples, you open up under SDK version 2, open up the SDK folder, Python folder, and scroll down to responsible AI. And the one that I've been looking at now is under tabular. And I started off with the housing classification model. For some reason or other, they've broken this into two steps. One step is I'll fit the classification, and another step is I'll do the ML flow registration, and then in a totally different step, they apply the responsible AI dashboard. I thought, why? So I wanted to do two things. I've taken the example, and I've first of all turned it into one pipeline, and the two steps that they've taken, I've turned it into one step. That's a logical way of doing things. Then I've taken a different data set about academical success, applied different models, and I want to show you how I get this to work. So first thing is first. One needs to, obviously, when you use the CLI jobs, you need to log in, turn on this particular flag, and then you can just, the way I like doing it is running the pipeline for the CLI. So if I run it this way, one can see that. I'll show you how it looks in my job. I go to this one. So first of all, in the example, they create first the training data set and the test data set as ML tables. And the whole process this step here assumes that it's getting ML tables as input. So also I follow that. And when you look in my code, when you go to the setup folder, there is the housing prices setup over here. So I've taken their code and just took part the section that creates the compute, that creates the ML table data assets, and if you just run that, you'll get those over here. Let's say the housing training PQ. It's an ML table, as you can see, and it's just a table with a few categorical variables and a target variable at the end. Now, I didn't notice this at the beginning, but with hindsight, I can now point out that if you notice, all the variables here are numeric, even the categorical variables are numeric. And I recommend staying with the encoded variables rather with labeled variables. Things break on the way when you try to diverge from that at the moment. The other thing that breaks is if I go back here, once I run the job, it creates a model. You can see here, for instance, I've run this job twice, and I've got two versions of the model. In the job at the moment, let me show you how it looks. Under pipelines and sorry, this one. So it assumes, sorry, this is the data. It creates a model called Demo 1, Responsible AI Housing Classifier Demo 1. That's fine. But when you run the classifier step here, it writes the model and hard codes the version as version 1. And at the beginning, I didn't understand why. Um, but now I do, after a lot of sleepless nights. Um, when you get to the rate job component, and you read in the path over here, if you try to on the way figure out what is the new model number that I have, there's no way when you're doing it in a CLI. Actually, it's also very hard to do it from the Python at the moment. So they just said, okay, what we'll do is we will create, each time you run this model in Python, we will add a timestamp to the model name, and always it will be number 1, and then I don't have to figure out what model number it is, either in code or outside of code. So when you go and you look at the code, you will see that in the original training code, there's a there's a time added to the model name, and I kind of use it when I go to the version of Python. But to make my life easier also, I've created for myself a job that you find in my code, and I put it under AML admin that just runs and deletes all the registered models I have. Because in any case, this is a demo environment. You can obviously modify this to just delete the models that you want. This is a Python notebook for a change, so I've done this using um, Python in this case. I did try to do it with the CLI. It's much more convoluted and less of a joy to do. So what you can see here is I've got the classification step. I prepare the responsible AI job. I, at the moment, chose to do just the error analysis, but you can see that there's placeholders here to go and do also the causal analysis and the counterfactual that goes with the causal analysis. And obviously the explanation could be very interesting. But I wanted to go one by one, and my next video will be about error analysis. So if I go back to my basic into the pipeline, oops, sorry, I went to the wrong place, jobs, housing, yeah. So in this case, I've just used the LGBM the same way as Microsoft has done, but I've just combined the two steps that they had into one component. And you can see the results here. If you go and open, you've got the error analysis that you can interact with. I haven't attached a computer here, but I definitely recommend to attach a computer so you can interrogate this in a much more interesting way, and I'll look into how to work with this and interpret it in the next video. You can also find this particular dashboard if you go to the first model. So if you go here now, you won't find it because this is already version 2. So the responsible AI say, I don't have anything, or yeah, it doesn't, and you can create it manually. But if I go to one of the other models, for instance, this was number 1, sorry, because it always hard codes it to number 1, responsible AI, and I've got here a job that I can, it's the same one exactly. Okay. So I said, okay, that was using the component, the LGBM component. You see, that originally they gave 2 steps. I turned it into 1 step. But I said, okay, why not also add gradient boosting and just add decision tree classifier. To get them to work, let me just show you what I had to do. So no matter what I tried, they broke at the beginning. What I realized was that to train the model, I needed the latest version of scikit-learn, but the environment that they provide does not have the latest version of scikit-learn. So for the tree classifier, I was able to just define my Conda environment here. You can see it over there with the latest scikit-learn and other packages that I wanted. And then all the issues were resolved and happy days. I couldn't get into the Conda definition, the JSON and the decisions installed, it breaks. So I just create the environment doing the pip install in the command line. Interestingly enough, I realized that I can do this only when I went into the environments and I said, no, curated environments. Yeah, the curated, sorry. Let's search for this one. Yeah, there we are. Let's take, I don't think it matters which one we take. Let's take the latest one. This is, and by the way, they're stuck with version 3.8 of Python. I have no idea. Well, I've got a suspicion that it's to do with the, the versioning of the packages that they're using, and they haven't found a way. Like I spent too much time trying to break out from 3.8 even to 3.9, and then Python versions don't work. And this is the vision, this is the responsible IO Ubuntu, and this is the text. Okay, so let's go for this one. And if you look at how it's defined, you will see that apart from using the Conda definition, it goes and does pip installs afterwards, right? Look at that. So this means to me that they couldn't fit all the installations and all the version package definitions into a nice Conda environment YAML definition. I'm hoping that the Microsoft will figure this out when it comes to putting it into general availability. But here's a way to do it. What I couldn't get to work is the gradient boosting, even though I tried the same trick. When it comes to reading the ML flow model that was created successfully, the responsible AI engine is not able to handle it. So let me show you what happens when I run it. So obviously, when you work in the pipelines, I've got a similar pipeline here that shows how to run the same process, but this time taking into as inputs the academic success training data set. By the way, if I just go back to my PowerPoint, a word about this. I was searching for some data to demo the responsible AI, which is not available, that not everybody is using. I thought, oh, look at this. This is a nice data set over here. I'll use this. I've been working with this now for about 3 weeks, tearing my hair out with the technology. And just today I saw that SAS is using something similar for their automatic reporting around performance of models. So I take in the model, so I take in the data, define a few class inputs, and then couldn't get the gradient boosting to work, but the decision tree works quite nicely. You can see here I'm adding the ending DTC because I'm preparing myself for, rather than just running one model, I got all 3 models running in my notebook, one thing that when you use Python that rather than the Azure CLI is when you load the components, you can just say, give me latest. In the CLI, you can't say latest. And when you run this, you'll see that the latest version is 0.14. You can see here that I'm adding a model. I'm just using the same idea that Microsoft have with adding the time to the name of the model, so you ensure that it's almost always version 1. You see, it's hard coded over here as version 1. I load the free components for the different models, classification models that I've chosen to use. In this case, I need to use the JSON dumps to hand over the lists. And you can see here I'm running the LGBM step, and I'm adding the LGBM text to the name of the model, and then I can refer to it in the next steps. And I do the same thing for the gradient boosting and for the decision tree, and just run it. And it will look like this. You can see that all the models have run successfully. However, when it comes to the responsible AI dashboard, I couldn't, for the life of me, get it to work with the MLflow version that comes out from wherever I tried from the gradient boosting. So, to conclude, although I personally prefer working with the AZ CLI to run the models, especially when one works with things that are in general availability, it probably is much better idea to work with Python. So you saw if I managed to get the notebook to work a little bit easier for me than in the CLIs. A few things were restricted. For instance, the model versions, getting that, and getting the latest AML responsible AI component. You have to hard code the number in the pipeline. Definitely, you have to list all the categorical variables in the dataset for the responsible AI, even if you didn't use them in the model itself. Because it says, look, it scans the data that you give it, and it says, I see here things that look categorical. I can't do anything, I break. And I tried one-hot encoding, and it did not pass through nicely to the responsible AI component. Just you have to do the hard code encoding first, build it into as a feature, not through the scikit-learn pipeline, and that won't work. So you need to work a little bit harder. And yeah, I already mentioned about the environment beforehand. There's an issue with regards to the installation of some packages, so you can install them after you get the environment going. Thank you very much for listening.